Okay, in this video, we're going to continue with the endocrine system, and we're going to answer, or we're going to cover these learning objectives. Why do we need hormone receptors? And number two, where are those receptors located? And what happens if a cell doesn't actually have a receptor? So I keep using that word receptor over and over and over, because really that is the key thing here in this video, is that we want to come away appreciating the role of receptors. So what is a receptor? Well, you see the word receive in there. And so a receptor is something that receives a hormone. So previously I've shown you this slide, and I showed you that this endocrine cell produces a hormone, it dumps it into blood at point A over here, and then it travels through the blood and then arrives at point B to then be received by the target cell. So the target cell, depending on the hormone, depending on actually the endocrine cell itself, that target cell could be anything. It could be skin, blood, bone, brain, all sorts of things, muscles, etc. And so what we see here is that this little orange thing, if you were to zoom in, you would see that that orange thing is actually a receptor. And what does it do? It receives the hormone. And from there, the receptor is the guy that's going to trigger the cellular response. One more time, the receptor is the guy that triggers the cellular response. Let me try to impress upon you how important that receptor is. So it's so important that, let's say we have some disease and that this endocrine cell no longer produces this hormone, okay? And so maybe it's your thyroid, maybe it's your ovaries, whatever. The point is, if this endocrine cell no longer produces this purple triangle, in some cases, doctors can just give you replacement hormone, okay? In some cases. In other cases, there's no exact replacement hormone. Instead, there's a drug that kind of looks like a purple triangle. It mimics this purple triangle, but it's not the same thing as the purple triangle. But what happens, it's close enough. And when it's close enough, it can trick that receptor into saying, hey, I'm the real thing. And then what happens? The receptor then initiates the cellular response, and you're right as rain, you're good as gold. So as long as you can convince the receptor that that hormone is out there, even if it's a fake, even if it's a fraud, that's how a lot of these drugs work. They trick these receptors into thinking, here I am. And then the receptor, again, triggers the response, and yay, everybody's happy. So really what I want to impress upon you then is this idea that the beauty here is not so much in the hormone. Yes, the hormone is necessary, but I just told you that sometimes through the miracle of modern medicine, the hormone itself isn't necessary. But you absolutely must have the receptor. To say it differently, if you had to pick your poison, no hormone or no receptor, right? You had to choose one, among those two awful choices. Which one would you choose? You should say, well, I'll go without hormone, because hopefully there's a drug out there that can pretend to be a hormone. But there is no way of replacing these receptors. So the receptor is the guy that triggers that cellular response. So for that reason, we need to spend some time talking about these receptors. The only thing I really need you to know are two things. First, these receptors are made out of proteins. So there you have it. They're made out of proteins. The second thing, though, is the location of these receptors. So where are these receptors located? Well, let's look at the cell itself. When you look at the cell, this is a cell. Let's look at that. Again, the outside of the cell, the so-called skin of the cell, is the cell membrane, right? You learned that in previous courses. Then once you get inside the cell membrane, but outside the nucleus, you have the cytoplasm, and then you have the nucleus inside. So we can think of this as being outside the cell. This is the cell membrane, this is the cytoplasm, and this is the nucleus. Well, the three possible locations of hormone receptors are those places, either on the cell membrane, located right on the cell membrane, or in the cytoplasm, or within the nucleus. Now, that picture that I keep coming back to, over here, where is that receptor located? Is that located on the cell membrane? Is it located in the cytoplasm? Or is it located in the nucleus? Pause the video, take a guess. And hopefully what you came up with is it's clearly located on the cell membrane, right? These little orange receivers, these receptors, are not in the cytoplasm. They're not in the nucleus. They're located on the cell membranes over here. So now you know that these are the three possible locations. So what we want to do now is we want to try to connect some dots with stuff that we learned previously, and we want to say, well, what were the types of hormones that we have again? The different types of hormones are amino acid-based hormones and steroid hormones, right? So we have these amino acid-based hormones, which are water-soluble, hydrophilic, another way to say that is lipophobic, and then we have steroid hormones, which are fat-soluble or hydrophobic. or lipophilic. Okay, and so we've covered these things. So the little comment I made here, thyroid hormone is actually an exception. Thyroid hormone is weird. Thyroid hormone is actually based on an amino acid, but it actually is fat soluble. It is not water soluble. So that is the one weird exception that you do need to know. Okay, so the question then becomes, in terms of connecting dots, amino acid-based hormones. Where are the receptors for amino acid-based hormones? And now you might say right off the bat, well, dude, you just told me there's cell membrane, cytoplasm, or nucleus. And yes, I mean, these are the three possibilities for receptor location, but specifically for amino acid-based hormones, where are those receptors? And the answer is, that's what this green arrow indicates, the answer is on the cell membrane. Okay, so now let's make this make sense. Let's make this make sense. If we go to this slide here, we can see that this is your cell membrane. And without going through all the details, I will just remind you that this is a phospholipid bilayer. The polar heads are facing the external aqueous environment and the internal aqueous environment. And these are long hydrocarbon chains, these long fatty acid chains, which are entirely hydrophobic. And it's highlighted over here. So now what I want you to imagine then is an amino acid-based hormone. And I'm going to indicate that here with this green circle. When the amino acid-based hormone is now floating through the blood and it travels, where is it going to bind to its receptor? Where is the receptor going to be? Now let's imagine for a second, let's just pretend that the receptor is right here. It's inside the cytoplasm. Let's just pretend that's the case. Let's go and match up the colors here to be consistent. So let's just pretend this receptor is located right here in the cytoplasm. So what does the amino acid-based hormone need to do to get to this receptor? Well, it's got to come here, and it's now got to diffuse through this phospholipid bilayer, and then it's going to come out on the other side to eventually bind to its receptor. Okay, so that's what needs to happen. The question is, can that actually happen? And the answer is, no, it can't happen. Why not? Well, here's why not. Amino acid-based hormones are what? They are hydrophilic. They are water soluble. Okay. On the other hand, when you look at this region right over here, it is hydrophobic. So can this hydrophilic hormone interact comfortably with this hydrophobic environment? And the answer is definitely not. Therefore, this is just not a possibility. Amino acid-based hormone receptors are always and forever going to be located right on top of the cell membrane. So this is going to bind there on the cell membrane, and then from there, there's all sorts of doohickeys here for this receptor to turn on activity inside the cell. Some of those doohickeys we'll explain in future videos. Okay, so that's why amino acid-based hormones bind to receptors on the cell membrane. So again, I'm asking you not to memorize that, but to make it make sense that water-soluble chemicals cannot diffuse through the phospholipid bilayer. Therefore, the receptors must be located on the cell membrane. Now, using that same logic, let's go and do the same thing for steroid-based hormones. Steroid-based hormones, where are their receptors located? And the answer is any of these locations. In some cases, cell membranes, in some cases, cytoplasm, in some cases, the nucleus. So let's make that make sense. Let's go ahead and get rid of these guys over here. Let's move them to the side. And instead, we'll have a steroid-based hormone enter the picture now. Okay? So now we've got a steroid hormone. And let's see. And what we're going to do now then is that I put ST here for a steroid-based hormone. And now that steroid-based hormone is coming through. And again, where is his receptor going to be? Is it going to be on the cell membrane? Is it going to be within the cytoplasm? Or is it going to be deep inside, located in the nucleus? Well, I've already given you the answer. And the answer is any of those places are possible. And so why is that the case? Well, because here's the thing. If I have a receptor right over here, true or false, that steroid-based hormone can come and just bind to the receptor. And you should say, yeah, I guess so. I don't see why not. Fine. Okay. Now let's take that receptor and locate it inside the cytoplasm. Can that steroid-based hormone come through, and can it diffuse through the phospholipid bilayer to come out on the other side to bind to the receptor? And you should say, yeah, because using the same logic we applied earlier, that steroid-based hormone, being a fat-soluble hydrophobic hormone, has no issue at all whatsoever entering into that hydrophobic forest of fatty acid chains and coming out on the other side. So therefore, you can have steroid-based hormones bind to receptors within the cytoplasm itself. And again, using that same logic, can this receptor be a little bit deeper into the nucleus? Why not? I can just go another, few inches or whatever. Not inches, but you get my meaning here. Okay, so that's why when we look at this, cell membrane receptors, these are always and forever going to be amino acid-based hormones. In some cases, they can also be steroid-based hormones. Okay, but cytoplasmic receptors that we see right over here, receptor hormone complex, and nuclear receptors, and actually on this picture you don't see a receptor in the nucleus. That's just because of this picture, but just pretend there is a receptor located right over here. These are always going to be only dedicated for steroid-based hormones, okay, because of all these solubility properties that I just talked about. So now let's go to that last learning objectives. We talked about why do we need hormone receptors. We know we need hormone receptors because these are the guys that trigger some activity inside the cell. Again, we'll take a closer look at that later. Where are the receptors located? Cell membrane, cytoplasm, or nucleus. And what happens if a cell doesn't have a receptor? What happens if a cell doesn't have a receptor? The answer actually is pretty obvious. So look at this endocrine cell. It's producing a hormone, and that hormone travels through blood and it diffuses out into the interstitium. So now this cell does not have a receptor. Therefore, there's going to be no physiological response. On the other hand, this one has a receptor bound to the cell membrane, as you can see, and therefore this one will have a physiological response. And so to answer the question very simply, what happens if a cell doesn't have a receptor? Well, it doesn't respond. It just doesn't respond to it. It's that simple. Okay. Now, in this slide, there's two other cool things that I want you to see. Here's a neuron, and we're kind of switching gears here. So I've said everything I want to say about receptors, but switching gears here, if we look at a neuron, we can see a neuron can spit out chemicals into the blood, which can then go into the blood and then bind to cells with receptors. In that case, we call it this chemical, we call it a neurohormone. In other situations, actually, that's all I want to say. Neurotransmitters, you already know. I don't need to rehash that. That's just when a neuron spits out over a synapse, a short space here, into the target cell. But when a neuron spits it into blood, we call it a neurohormone. And this is going to go back to what I was talking about in that introductory video where I said that both of these things, the endocrine system and nervous system, are regulatory systems. They're married together. Where one ends and the other begins, who knows? So this is kind of evidence of that. So this is clearly a neuron, but yet it's kind of acting like a hormone here because of the fact that it dumps these chemicals into blood. So because of that, it's kind of acting like a hormone. So what is this thing? Is it a neurotransmitter since it was produced by a neuron? Or is it a hormone since it's a chemical signal that travels through blood to go to its target cell? And the answer is, is it glass half empty or half full? Yeah, I guess it depends. So let's just call it a neurohormone here. All right. I don't have anything else to say about this. The point here in this section is really to emphasize that the nervous system and endocrine system are married together. What I highlighted here, what do all these have in common? Whether you're a neurotransmitter, whether you're a hormone, whether you're a neurohormone, what do they all have in common? They're signals to regulate activity of other cells. That's what they have in common. Okay, so to recap our video, we've identified the location of hormone receptors. Actually, that wasn't, I forgot to change it. I changed it to why do we need hormone receptors? I just forgot to change it in the recap slide. Why do we need hormone receptors? Because you need that to initiate cellular activity. Where are they located? I told you those three places. What happens if a cell doesn't have a receptor? The cell just doesn't respond. And that'll wrap up this video.